Welcome to my algebra class. We're on chapter 5, section 7. And we're going to start learning how to factor trinomials that are not perfect square trinomials, because that's not always going to happen. And we're just going to take it one step at a time. So we're going to work with a trinomial where there's no number in front of x squared, just the 1. And the number, the third number, the term, the constant is positive. So the coefficient of the quadratic term, the one that's to the x to the second power, is 1. We know if it works, if there is a pair of factors that work, two binomials, that when I multiply I get this x squared plus bx plus c, then the square root of x is x, and the two numbers that work, and if I do FOIL, I get x squared, I get sx and rx plus rs. So I can see that the middle term is going to have s plus r will be the number in front of x, and the last term is going to be rs, whatever those numbers are. So I can use a rule that I'm looking for two numbers, r and s, whatever they might be, that add up to the number in front of x in the original trinomial. And I'm looking for two numbers, when I multiply them, I get the constant, the last number in the trinomial. And if you can't find any two such numbers that work, you call it prime. I think you'll understand it better when you watch the following problems. So for this first example, I have y squared minus 8x, y plus 7. So I know y squared is a perfect square, so I'm going to take the square root of that. Now I'm looking for two numbers whose product is, remember the product is that middle, the last term here, whose product is 7, and whose sum, the outer and inner terms, when I do FOIL, come up to be negative 8. So if I think of the factors of 7, since the product must be 7, I have 1 and 7. That adds up to 8, but they both have to be negative. So a negative 1 and a negative 7. So if I have y minus 1 and y minus 7, that would work. If I check it with FOIL, y squared minus 7y minus 1y makes the negative 8y plus 7. The next example, the square root of y squared is y. The product has to be 30. The two numbers that I find here have to multiply to 30, and they have to add up to positive 17. So I just think of the factors of 30. 1 and 30 do not work. They do not add up to 17. 2 and 15, those two do work. 2 plus 15 makes 17. 2 times 15 makes 30. So I have one of the factors has to be y plus 2, and the other one has to be y plus 15. And it doesn't matter which order you put them in. The third example, take the square root of y squared, which is y. The product is 20, and the sum is 9. So using the factors of 20, 1 and 20, there's no way to get 9. 2 and 10, nope. 4 and 5, 4 times 5 makes 20, and 4 plus 5 makes 9. So y plus 4 and y plus 5 would work. And you can always use FOIL to check. Y squared plus 4y plus 5y makes the 9y plus 20. And the last example, take the square root of y squared. I need a product, two numbers that multiply together make 36, added together make 18. So taking the factors of 36, 1 and 36 do not work. 2 and 18 add up to 20, that won't work. 3 goes into 36, 12, that won't work. 4 and 9 make 13, and 6 and 6 make 12. So this is not a perfect square trinomial. Excuse me, it's not, I didn't mean to say that. It's just prime. If it doesn't work, you just say prime. I'm still thinking of the last one. If you want to copy your vocabulary right now, you can do that. It's here. When you're done, we're going to be doing the even, so you can pause me until that finishes. We're on page 215, written 1 to 30. Paper's folded, headed. You have your title, and we are starting with number 2. Copy the problem down. Z squared plus 9z plus 8. I want to see the work. I want to know what you think the product is and what the sum should be. The product is 8. The sum is 9. And the factors of 8 that work, 1 and 8 is the first pair, and actually it's the first pair that works. So we're going to put the factors down, take the square root of z, which is z, square root of z, square root of z, and one of them should be plus 1 and one should be plus 8. And you can check it with FOIL. Z squared plus 8z plus 1z makes the 9z plus 8. So your work is to write the problem down, tell me what the product should be and the sum should be, and then list your factors until you find the 2 that work. After a while, you get pretty good with this, and you could probably find the 2 that work a lot faster than just listing them all. Number 4, it's c squared minus 10c plus 16. Make sure your trinomial is in decreasing order or increasing order, but they do have to be in order. So our product needs to be 16, the last term here, and our sum needs to be negative 10. And the factors of 16 are 1 and 16, that doesn't work, 2 and 8. 2 and 8 work, but they both have to be negative. So we have the square root of c squared is c, and we need 1 minus 2 and 1 minus 8. Problem number 6, p squared minus 14p plus 13. The product is 13. The sum is negative 14. The factors of 13 are just 1 and 13, and those 2 numbers will work, but they both have to be negative to make negative 14. So factor, take the square root of p squared, which is p. One of them has to be minus 1, and one has to be minus 13. Number 8, we have n squared plus 10n plus 21. Product, the 2 numbers we're looking for have to have a product of 21 and a sum of 10. The factors of 21, 1 and 21 do not work. 2 doesn't go in. 3 and 7 do add up to 10 if they're both positive. There's our solution. So the square root of n squared is n. One has to be plus 3 and one has to be plus 7. Problem number 10, we have s squared minus 12s plus 40. The product of the 2 numbers has to be 40. The sum has to be negative 12. The factors of 40 are 1 and 40. That doesn't work. 2 and 20. 3 and does not go in. 4 and 10 do not work. And 5 and 8. So there were no pairs that work, so this is prime. Number 12, z squared plus 16z plus 39. The 2 numbers we're looking for have to have a product of 39 and a sum of 16. So the factors of 39 are 1 and 39. 3 and 13, and those 2 do add up to 16, and we want a positive 16, so they're both positive. So z plus 3 and z plus 13 would work. Problem 14, we have x squared minus 22x plus 72. Our product has to be 72. The sum of the numbers has to be negative 22. So 1 and 72 do not work. 2 and 36 do not work. 3 goes in there, 24. That doesn't work. 4 goes in there, 18. 4 and 18 add up to 22. They both have to be negative. So the square root of x squared is x. One of them has to be minus 4 and the other one minus 18. Problem number 16. This is in increasing order. It's okay to leave it this way. Product has to be 64. If you leave it this way, just realize the product is at the beginning. You could rewrite it as s squared minus 20s plus 64. Doesn't matter. And the sum is negative 20. So the factors of 64, 1, and 64 do not work. 2 and 32. 3 doesn't go in. 4 and goes into 64. 16, those are the two I want, but they both have to be negative. So it's, if I do it this way, it'd be s minus 4 and s minus 16. I think your book left it this way, which would be negative. Let me see what they do. Now they have, I think it'd probably be easier just to turn it around this way from now on. So let's keep them in decreasing order, and then we won't get totally confused. So the book, I think, has it turned around to minus s plus 4 and minus s plus 16. But we'll leave it this way. Okay, number 18. So again, this is in increasing order. I'm going to turn it around. So it's u squared plus 27u plus 75, so it's in decreasing order. Product is 75, sum is 27. And the factors of 75 are 1 and 75, 3 and 25, that doesn't work, and 5 and 15. And after that, there are no other pairs, so this is prime. And the next set of problems, 20. You'll notice that there's a variable with the last term in these. You have a squared plus 10ab plus 24b squared. So our product has to be 24, and our sum is 10. And the factors of 24 are 1 and 24, 2 and 12, that won't add up to 10, 3 and 8, 4 and 6. So those are the two numbers I want. So it's going to be the square root of a squared is a, the square root of b squared is b. So I have an a and a b. And I need to have one be plus 4b and the other one plus 6b. So you have to take the square roots of the ends. Number 22, you have x squared minus 15xy plus 72y squared. So it's in decreasing order, and the product has to be 72 and the sum negative 15. So two numbers add up to 15, negative 15. 1 and 72 do not work. 2 and 36. 4 and 18 do not make that, and we're already past, we get to 6 and 12, we've gone too far. So it's prime. No pairs work. Number 24, we have h squared minus 14hk plus 49k squared. Product has to be 49, sum has to be negative 14. Factors of 49 are 1 and 49, definitely do not work, and 7 and 7, which do work. And since it's negative 14, they both have to be negative 7s to add up to negative 14. So factoring, square root of h squared is h, square root of k squared is k, and it's minus 7 and minus 7. And perhaps you notice this was a perfect square trinomial, which we can shorten as h minus 7k quantity squared. So this method works also with a perfect square trinomial. 26, you have m squared plus 20mn plus 51m squared. Product is 51, sum is 20. The factors of 51 are 1 and 51, that does not work. 2 doesn't go in. 3 goes in 17 times. So there's my numbers, and 3, positive 3 and 17 work. So the square root of m squared is m. The square root of n squared is n. One of them has to be plus 3n, and the other one plus 17n. 28p squared plus 20pq plus 50q squared. Product is 50. Sum is 20. The factors of 50, 1 and 50 do not work. 2 and 25 do not work. And 5 and 10 do not work. So it's prime. Those are the only factors of 50. And the last problem, number 30. A squared minus 12ab plus 27b squared. Product is 27. Sum is negative 12. So I'm looking for two numbers added to negative 12 that are factors of 27. So 1 and 27 do not work. 2 does not go in. 3 goes in 9 times, and 3 plus 9 makes 12. They just need to be negative. So the factors, square root of a squared is a, square root of b squared is b. So ends are a and b. One has to be minus 3b, and the other one plus, minus 9b. That concludes the evens. Be sure and check the back of the book for your odds, the answers.